All right, good morning.
Good morning.
All right, that's what we. All right, you guys can do better than that. All right, let's try this again. So all you people were shouting out to Patar, who's going to be watching this later in advisory. Good morning.
Good morning.
There we go. All right, good. Okay, so we're continuing 5-5. My notes on 5-5, so hopefully everyone's going to be like, I got this. Okay. Now, whenever I'm actually doing these problems right here, you see this, and it should be one of the things you're like, hey, that's ugly. I don't like that. Right? Now, remember, I had you guys try to memorize a whole bunch of stuff about the antiderivative, right? Or the derivatives. Okay, so now I have to look at this and be like, hey, you know what? There is a derivative here. I just got to figure out where it is. So there is a derivative here. I just got to figure out where it is. So, does this look like it could be a derivative? It almost looks like arc sine, right? Now, we are going to try, since it almost looks like arc sine, let's see if we can make it into an arc sine. So that's going to be part of my U substitution. I'm going to make it fit my math. That's what we're doing. We're actually creating it and making it fit what I want it to fit. So, for right here, I am going to change it up a little bit. I'm going to change it up. So, I know that with arc sine, it's supposed to be on the bottom, it should be the square root of 1 minus x squared, right? Say yeah. Okay, good. So, that's what I'm going to try and make it into. By doing that, I need to have a 1 here, don't I? So, can I divide out a 4? Yeah, that's what I'm going to do. Oh, okay. Bye. Okay. All right. Okay, so let's take a look. So I'm going to go, and I'm going to change this up. So I have integral of 1 over 4 quantity. Sorry, when I factor out that 4, what's going to be left? Divide out a 4. I'm going to get 1 right here minus, how would I show this next part? 1/4 x squared, right? 1/4 x squared. So I'm going to go x squared over 4, right? And that's all right there. Oh, man, my board needs to be lined up. All right. So now it looks kind of like it. I'm almost there, right? But isn't that 4 multiplying by this thing over here, right? So it's a little bit more creative math here. Right there, all I did is I separated those because I factored out a 4, and now I have the square root of 4 right there. But what is square root of 4? 2. Is that going to be a constant? Is that going to be a k? That's going to be my constant k value. So what can I do with it if I don't like it over here? I got to take it out. Can I bring it all the way out in front of my integrand, right? So let's see. So it's going to be 1 over, we said square root of 4 is 2. Integral of 1 over square root of 1 minus x squared over 4. All right, so now, what is my issue here? Okay, so it's x squared over 4, where in my arc sine I normally just have an x squared, right? So I know that's going to be my issue here. That's going to be my issue here. So let's take a look. I'm going to try and make this work. Okay, to make this work, I'm going to change this up a little bit, and then it's going to turn into, let's see, equals there we go. I have x squared over 2 squared. Isn't that still my x squared over 4, right? I just took it out to make it work. All right, what do I have to try and do now? U equals what? X over 2, right? That's what I need to do now. So I'm going to actually add some more. Another page here. Insert page. So now we said that U equals X over 2. So I have 1/2 my integral of 1 over square root of 1 minus U squared, right? Yes? Okay, so let's du. So du is equal to 1/2 dx Okay, so what am I replacing my dx with in this case? Not 1/2 du. 2 du, right? Because I gotta get rid of the 2, right? So it's a 2 on bottom, so I'm gonna multiply both sides by 2, right? So it's gonna be a 2 du is equal to dx. So I'm gonna go times 2 du. But don't I already have a 1/2 out front? Yes. There's a 1/2 out front, so I could cancel the 1/2 and the 2, can I? So that means that I'm going to be left with the integral of 1 over 1 minus u squared du, which is going to give me what? We said it's going to be arc what? Arc sine. Arc sine, arc sine. So this is going to turn into arc sine. So integral, so arc sine. Arc sine of u, am I forgetting anything?
C.
Plus c. All right, and from there, what do I have to remember? Plug it back in. So, need to go ahead and plug back in. So, it's going to give me arc sine of x over 2 plus c. You guys know that I could write arc sine like this, or I could also write it with the -1. So I can write it both ways. Okay, I don't want you guys to think of this as a negative exponent though. Okay, so arc sine. I like writing it like this. With the arc, ARC, makes life easier. All right, are we okay with that one? Oh, I left off my dx everywhere, didn't I? Okay, so let's be creative and think about this one here. So dx over 9 plus 4x squared. I'm going to another page here. What did it say?
4x squared.
Like that? Okay. All right. What derivative does this one look like? Arctan. Arctan. So remember, ln is 1 over x. Right? 1 over x is ln. So this looks like it could be an arctan. So now, if this is going to be an arctan, what do I have to do to try and make it? Do you remember what arctan has on it? What's arctan on the bottom? 1 plus x squared, right? Arctan on the bottom is 1 plus x squared. So that means that I need to try to make this into that. Okay? Let's start by making it by having the 1. What do I do to make it have that 1? Factor out of 9, right? Factor out of 9. So that's going to turn into integral of, let's see, dx over 9 times 1 plus 4x squared over 9. That's super ugly. My board's not lined up. Now, I kind of did it again, didn't I? I made it. I got that 1 there to make it an arctan. But now, what do I have to do? I gotta have something squared there now. I'm gonna change that to what? 2x over 3 squared, right? So, let's see. I'm gonna take out that 9. I'm gonna take out, so in front of my integral is gonna be 1/9 integral dx over, it's gonna be 1 plus parentheses 2x over 3 squared okay, and u is going to be 2x over 3. Okay, so you guys are going to do my du for me. All right, so what do you think my du should be? So it's going to be du is equal to 2/3 dx. So I'm going to replace dx with 3 over 2 du, right? Because I'm going to multiply by the reciprocal here, right? So it's going to be 3 over 2 du. Now, that 3/2 is going to be a k. That's going to be a constant multiplier in front of it, so I could factor that out. Okay, so I'm going to put that out in front, but I already have a 1/9 out there, right? So if I bring that out there, what am I going to end up with? It's a k value. So it's a factor, so therefore it's a multiple, right? So if it's a multiple, that means I'm factoring out front. If there's already a 1/9, what's that going to become? 1/6. Very good. So it is going to be a 1/6 because I'm multiplying 1/9 times 2/3. 3 will reduce, and there's a 3 on bottom and a 2 on bottom. So I get 1/6 integral of my du, right? Du over 1 plus u squared. All right, Watcher, what do we get now?
1/6 tangent to plus c.
Very good. So that's going to be 1/6 arctangent of u plus c. And what am I doing here? Plug it back in. Plug it back in. Very good. So 1/6 arctan of 2/3 x plus c. Yay! You guys feel good about it? Questions? Okay, remember back in the day when I said, hey, these are important, I need you to memorize these? Here's a whole bunch of flashcards. Yeah, about those, right? So if you guys could, please, 5 minutes. I'm asking you 5 minutes each day. Keep them in your pocket, or you're going to be one of those people. There's like a quiz thing that goes with Remind. There's like a flashcard app. If you actually have the Remind app, it actually gives you choices for it. There is like a little quiz, like a little flashcard thing that you could do on your own. 5 minutes. Grab your stack of derivatives, because the integrals become so much easier if you know your derivatives that we treat like identities. Okay, we're not doing the math all the time for what is the integral of tangent. Okay, we're not doing that, because I'm gonna just give you that and say, hey, you know what, this is what it is. Okay, what's the integral of secant squared? There's my tangent, right? Okay, this is important. So because they were the derivatives, we're doing antiderivatives, and you don't have to do all the work anymore, because we've already did that when we did the derivatives. We know it goes back and forth. Find a definite integral using substitution. Find two approaches. Find definite integral using substitution. Method 1. Find the related indefinite integral using substitution. Then use the fundamental theory of calculus. Okay, top minus bottom, right? Okay. So 2. Find the definite integral by directly making substitution into the integrand and using substitution to change the limits of the integrand. Didn't we already do this one?
Yeah, but we didn't like.
Okay, so let's see. What did I actually come up with when I did this? And it's funny because it's still on the board. I'm staring at it. Okay, this is a couple examples ago, so it's over there on the left. Let me see. So I'm going to write it out. So it was, the integral came out to be, what's that? 2 over 5. And that is 4 plus x, 4 minus x, right? Oh, this is not the same one.
No, all the x not squared.
Oh, all right. Okay, it's not the same one. I thought it was. I was like, hey, that'd be so much easier if it was. Anyway. All right, so the problem we had the other day, really close to the same thing. Okay, maybe because it all looks familiar because I've done them all so many times. All right, so what's my u in this case? Remember, it's a chain rule, right? If I were to take a derivative, it's a chain rule. What's the chain that makes it messy? 4 minus x squared, right? So we're going to choose that, okay, and I'm going to make this work for me. So I'm going to say that u is equal to 4 minus x squared. So my du is, yep, negative 2x dx. Very good. All right, and what's the piece that I do not like? I don't like that negative 2, do I? Because I know that I'm going to use that x, the x dx for my substitution, right? I'm going to use the x dx for my substitution. It's the negative 2 that I got to get rid of. So I'm going to divide both sides by negative 2. All right, so isn't that going to be my constant k, right? Say yes. It's going to be a constant k. So if it's a constant k, what can I do with it? Move it out all the way in front. Okay, I'm going to move it out all the way in front. So it's going to turn into the negative 1 over 2 integral from 0 to 2 of, let me see, the x is going to go away, the dx is going to go away, and I'm going to be left with u to the 1/2 du. Jess? Okay, good. Now, that turned into a whole lot easier of a problem, didn't it? That substitution, nice. That's a nice. All right, go ahead. Do my integral. Integrate it. So I'm going to have my negative 1/2. I'm going to bracket that because that's my constant. And so it's going to turn into, let's see, u to the, do your exponents first, right? 3/2. And so it's going to be times 2/3. And do I put plus c? Why do I not put plus c? It's definite integral, and it's going to be a top minus bottom, right? So I'm technically going to be adding a c and I'm subtracting a c, but the c goes away. So, and we have from 0 to 2. Now, so remember, these bounds are in terms of x, right? In terms of x. So what do I need to do? I need to put it back, right? I need to put it back. So let's go ahead and I'm going to go ahead and put it back. So that's going to give me my negative 1/2 of my 2 parentheses 4 minus x squared to the 3/2 over 3. Yes? Okay, yeah. And from 0 to 2. Okay, you people, right now, math this. Do some math. I might have done my math wrong too, so I just winged that one. Nope, it's right. Is that what you got, Watcher?
Huh?
Is that what you got?
Yeah.
Yeah?
Okay,
Okay, good. Alright, so let's see. So if you guys doing the math on this, 2 squared is 4. 4 minus 4 is? So all that's 0, isn't it? Okay, all the top is 0. But the bottom is going to give me 4, right? So it's going to be 4. Remember, the power is like this. So the exponents, it's going to be a power on the top and a root on the bottom. So I got to take 4. What's the square root of 4? 2. The square root of 4 is 2. 2 to the third power is 8. 8 times 2 is? It's all 16 over 3, right? It's all 16 over 3. So it's a positive 16 over 3, right? Okay. But this is the lower bound, so it turns into a negative 16 over 3. And then multiply by my k. So the two negatives make a positive. So my 16 over 3 times 1/2 is positive 8 over 3. Okay, so now I'm going to do the same thing. Okay, same problem. Okay, I'm not going to do all my substitution. I'm going to start right here. So right here, I'm going to do a new page on this one though. Because there's two ways of doing this. So what do we have? We had negative 1/2 bracket 2 no u 3/2 over 3 from 0 to 2. What was my u value?
4 minus x squared.
Okay, 4 minus x squared, right? Okay, so this is the other method for substitution. So we can substitute my bounds also. So the first way, I plug it in, and then I put it back, and then plug in my definite integral. Plug in the numbers for my definite integral, okay? We're going to get into some crazy math. And the crazy math is going to require multiple substitutions. So that means that you're going to end up substituting once and then substituting again. So this technique that I'm going to show you is going to help for the harder problems. Okay? The other one is kind of easy. It's what we know, what we've been doing. Now this way also works too, especially with the u substitution. So in this case right here, what is my x value is 2, right? My x value is 2, so plug in 2. Okay? What is going to be, so that's going to be 4, right? Okay, 4 minus 4 is? Okay, so I'm going to u sub my bounds. Okay, now plug in the lower bound. Plug in the lower bound, what do we get? So we get 4, right? So u is equal to 4. What's wrong with those bounds now? They're backwards, so what could I do to fix them? Make it positive, right? So positive 1/2 now, right? So now it's going to be a positive 1/2 bracket 2u to the 3/2 over 3 from 4 to 0. And so let's go ahead, my constant out there. So now let's top minus bottom. So plug in 4. So the square root of 4 is 2. 2 to the third power is 8. Times 2 is 16 over 3, right? So I have a positive 16 over 3 minus the bottom here, which is going to be 0, right? There we go. Okay, so we're left with just 16 over 3 times my k, which is 1/2, which is going to give me a positive 8 over 3. Do you guys feel okay about this? I'm hoping so. At least okay.
So, do you want us to use that version or the other version?
Either way, they're both the same thing. They're both the same thing. It's just,
You don't-
what was easier about this?
You didn't have to sub.
You don't have to put it back, right? We substituted an ugly part for an easier part, right? And all I have to do is just change my bounds, and then I just continue with that. So this way is slightly better, slightly quicker, for just about all of them, whichever you feel comfortable with. Okay, I'm gonna leave off there because I'm gonna give you guys the 20 minutes, about 20 minutes left to work on this, please. So please work on this. Please practice. This is important. All right. Don't forget Patar. Like, share, and subscribe. and Q, who was, shout out to Q. Anyone else we're shouting out to? Nope.